Passiamo al secondo relatore, che è arrivato qualche ora fa da Lubiana. Miha Tomaževič è un professore ed esperto sismologo di Lubiana. All'epoca ha partecipato attivamente col suo alto contributo tecnico alla ricostruzione antisismica di alcune case danneggiate dal sisma, fornendo poi, tramite l'Università di Lubiana, un programma di verifica di calcolo statico per la ristrutturazione delle murature delle case in zona sismica. Questo programma, metodo POR, che ha nominato anche Miro nel suo intervento, fu usato da tutti i calcolatori, ingegneri, architetti, geometri e periti edili coinvolti nella ristrutturazione e ricostruzione delle case terremotate in Friuli. Allora la parola al signor Tomaževič.
I'll present the institute where I come from and speak also of our experiences which led us to assist colleagues in Italy after the earthquake of 1976. Then I will, as an engineer and researcher, speak about the basis of what we have contributed and what's all about. Speaking of reconstruction or strengthening of these stone masonry houses, there are very simple principles, but you have to understand what is. Shall we translate or we go on? And then I will come to the point, the activities of our institute after the earthquake of 1976, and continuing and still ongoing the transborder collaboration between the colleagues of both sides of the border.
Sì, quindi vedremo nella presentazione vedremo la loro esperienza prima del terremoto, durante il terremoto, dopo il terremoto e poi collaborazione loro con esperti italiani, no? Perché sì, loro sono arrivati, istituto ZRMK in pratica è questo istituto che guidava il professore con il quale ha portato conoscenze antisismiche in Italia. Vediamo adesso com'è.
Well, I will not speak about the institute, just you can read this here. The institute, which existed in 1976, was named Institute for Testing and Research in Materials and Structures, ZRMK. After Slovenia became independent and the system was changed, the institute was separated into two parts. The one remained the public research organization. Today it's called Slovenian National Building and Civil Engineering Institute, short ZAG, we say. The other part became a private enterprise and is mainly interested in design of complicated or not so simple structures, and traditionally they're also executing the enterprise, the repair and strengthening, reconstruction of existing buildings. Well, the first encounter with the institute, or with earthquake of our institute, was in 1963, Skopje earthquake. This was the most, I have to say, devastating earthquake which affected our former homeland, Yugoslavia. And the institute was assigned, since it had some experience in masonry construction, to take care for masonry buildings, mainly brick masonry buildings, because in big cities there are no stone masonry houses. And the second opportunity to learn about earthquakes was the Banja Luka earthquake in Bosnia and Herzegovina in 1969. The typology of the buildings there, Banja Luka, was not only masonry, there were also reinforced concrete structures and so on and so forth. So we a little bit widened the research and even further took some specimens of masonry walls for the buildings and brought them to Ljubljana to the institute and tested them there. So in collaboration with the Skopje Institute for Earthquake Engineering, we designed some reconstruction or strengthening of those buildings, and we were lucky to see how these buildings behave, because also in that area of Bosnia and Herzegovina there was an earthquake in the 80s, I think. I don't remember the year, so we went there to inspect the behavior of the strengthened buildings and found them very satisfactory.
Come si è visto, due principali diciamo, esperienze che avevano sono due terremoti, uno di Skopje in Macedonia e uno a Banja Luka in Bosnia e Herzegovina. Loro quindi erano anche come istituto erano attrezzati, cioè forse più attrezzati di molti altri stati, avevano anche questa tavola che poi vedremo, tavola vibrante, e portavano i muri delle zone terremotate, portavano muri a Ljubljana per fare le prove su quei muri, no? E quindi cercavano di capire come fare la riparazione delle case lesionate.
Well, the first meeting with stonemasonry, which are the typology of these houses, is very similar to those in this region, also in the region of the Val di Zonza, on the Yugoslav-Slovenian part of the border. We encountered them in 1974. We had a very rather moderate earthquake, which affected a small part of Slovenia. And then we decided to strengthen them, but by very simple methods. Strengthen the wall with injections with cement grout. At that time we used cement grout, just very simple, without some specific additives which we are used after that. And we would also like to see what is the effect of these methods which we proposed. A bunch of rubber. Nothing. So what can you conclude out of this? The only conclusion is that the buildings built in this way are not earthquake resistant. And the picture on the bottom side, then left side, is how did the city of San Francisco look after the earthquake. You see, there was a good paper written on the occasion of the 100th anniversary of the earthquake. It's well known that after the earthquake, the general opinion was that masonry buildings are not earthquake resistant. But if you look at the situation just after the earthquake, these are all masonry buildings, 5-6 stories high. And nothing happened. No, not even windows were broken. But the fire came and the fire demolished just simply there. You can learn from damage. If you look at the damage and you see what's happens during earthquake, during vibrations, and usually, I will not go into details, I'm still already speaking too much, from separation of walls to autoplane walls, which obviously led to conclusion that we have to keep together the walls act during earthquake. So to change the structure into a homogeneous box. In other words, maybe we can say if us individuals, we are weak, but if we come together, we help together, we become strong. And the other thing is, just then you will explain, and the other thing, of course, also very important, is that the structural elements are sufficiently strong to resist the forces which occur during earthquake. If they are not strong, not even if they work together, they will not help the building to become. So this is the first testing of stone masonry which we did after this earthquake, before the Friuli earthquake. We also had some, but already had some even experimental evidence that the methods which we are using is helping the houses, the buildings to resist earthquakes. And on the left-hand side is a small model of a stone masonry house, which we were tested on a very simple shaping table we had at that time at the Institute. And on the left-hand side is the example of testing of effect of grouting the stone masonry, the poor quality stone masonry wall with cement grout. And you can see the difference. The lower curve is the, we call it resistance curve. In the case of the original non-strengthened wall, and by grouting, the resistance is increased quite significantly in that case. So we had some information about that when Friuli earthquake occurred. So I think it's not necessary. Well, this is the principle of what we achieve when we connect the wall, tie the wall with wall ties. This is an example. This is, well, after Friuli at the end of 80s or the beginning of 90s, we decided to test a little bit more systematically to propose some mathematical model how to evaluate, how to design the ties. It's not, you know, people who are here of my age and a little bit younger, remember that we just said that maybe the diameter of 20 millimeters or something like that was okay, without any calculation or whatever. But it turned out that it was the right decision. So here you can see in the case of the brick masonry, what happens if the building, we tested this on models, not on the real size structure, how this connecting of walls with wall ties helps and changes the behavior of the wall. I will show you now, I hope it will work, two video clips of the two models. The left has a stone masonry without wall ties, and this is, you see the difference? The building with ties, but the strength of the masonry was the same because nothing. Of course, the second building connected with wall ties collapsed, but the upper story remained more or less undamaged. At the same time, not the same project, we also systematically studied the effect of grouting. The idea was to design the grout strength. So if you need a stronger wall, you inject stronger mortar. And the Institute was, of course, involved in the activities in both sides of the border. Maybe I will pay a little bit more attention to our collaboration here in these parts of the country. So after the May earthquake, they were practically not really real activities of reconstruction taken in Slovenia, because we were waiting to analysis of damage be finished, and on the basis of this analysis of damage, start planning the activities. But at the same time, the Slovenian government decided to assist our minority, which lives maybe east of Palmanova, near the Slovenian border. So sent Slovenian experts to prepare design plans for reconstruction of the damaged buildings, and also to assist and educate people working in a rather small construction company, Benedil from Cividale, which was led by Dino Del Medico. And within this program, the Institute chose 3 buildings as a pilot examples of the efficiency of these methods of strengthening. And one was located in Luzedara. Here is the rough structure on the left-hand side. This was in the not reconstruction of the building was not yet finished, but this is the structure itself did not suffer any additional damage after that. And this building became, how to say, a TV star or something. So everybody came and looked at that. And on the basis, on the left-hand side, is the building
Sì, solo perché questo è il punto essenziale, è questo, no? Che il professore spiegava. La casa a sinistra è casa appena legata da loro con i tiranti e con iniezione di cemento, e questa è la situazione dopo la scossa di settembre. Quindi con la scossa di settembre questa casa non ha subito ulteriori danni, le case in giro sono crollate, quelle che hanno iniziato a crollare a maggio, a settembre sono crollate, quindi questa è rimasta in piedi. Con questo la regione si è convinta che il loro metodo è corretto, che si può utilizzare, e quindi è entrato a far parte, il professore con la loro esperienza, quello che dicevo prima, è entrato a far parte del gruppo interdisciplinare centrale, eccetera. La foto a destra è la stessa casa oggi, questi mesi, qualche mese fa.
Come to the end, and well, on the basis of this good behavior of this, well, the experts of our institute have been asked by the Camera Engineering Division to hold a series of seminars, and I am very blessed to meet today a gentleman, he's sitting there, Engineer Giuseppe Suraci, which was, I would say, glad to say, maybe the father of the famous Documento Tecnico numero 2. Well, this paper, this document was, at least draft of this document was prepared in his office we spent many hours discussing what to insert, how to, so on and so forth. And the maybe important part of this contribution of ZRMK at the time was also the computer program, or very simple thing, and this was checked and translated into Italian in the office of Dino D'Orlando, mi pare. D'Orlando, sì. Lui aveva un calcolatore abbastanza forte, and so we checked this. So this is the main result of the main contribution of Terremoto or I'm sorry to have been wrong, but